But there is a task that's out now, which is task 1. And when I say it's out now, I'll DACL it at the end of the course. And task 1 is this. Java is the language we'll be using in this course, and often people ridicule it cruelly, I think, for being slow as a dog. And C is fast as a greased dog. And certainly that was true in the old days, but these days the people that love Java say, Java is so fast, it's almost faster than C. And we all know that's not possible. Einstein proved that. And the C people say, no way, Java's just slow as an old dog. So depending on who you ask, you get different answers. So your first task is this. Run some Java and run some C and write a report telling us which one's faster and why. Well, we know which one's faster. Write a report on the relative speed difference of the two. Use your scientific brain from 1927 to do some experiments to produce a meaningful result, to answer the question. And all the questions, by the way, to make everything really practical, in this course at the moment, Google is actually going to pay everyone in this course, and you are all now employees of Google. And your new hires and your boss, not called Gary, but Eustace, I'm not sure why. Gary's next level up, or Claude's, and then Gary. Your boss keeps giving you these tasks. And he says, I need this by 5:45 on Friday, or whatever time. So I want you, when you're doing the task, not to think of some abstract lab task. It's, you've got a job, you're working on your job, your boss has given you a job. And this is the sort of thing your boss would do. So the first task, when you look at the page, it'll say something like, Gary comes up to you and says, we're thinking of using a bit more Java in Google. Currently, we tend to use a fair bit of JavaScript and C++, but, and certainly all our core stuff's written in that. But now we're thinking Java's better and we're thinking of using it, or some people saying that. But I'm nervous because someone told me that it ran like a dog. Can you find out and just do a quick report that I can show to Gary saying whether it's worth us switching? So they don't want a little theoretical thing, and they don't want a report that doesn't answer the question. They want you to go away and do some sensible tests and come back with meaningful numbers. Now, you don't know how to program much in Java. In a sec, I'll show you how to do a bit of programming in Java. You actually know more Java than you know, because Java is essentially the same as C with some extra bits. So you could probably read a Java program at the moment, a lot of it would make sense. The extra bits are the object orientation that we'll be looking at on Thursday. But so the basic Java looks a lot like basic C. So, I don't know, maybe someone will decide to write a program to sort numbers, a bubble script, a bubble sort algorithm in Java, and they'll implement the same algorithm in C, and maybe they'll even use the same code for both, because it'll look very, very similar. And maybe they'll run them both on different sized inputs and produce a report based on that. And maybe other people think, that's not really telling me about the speed differences between the languages though, and they'll think of another test. Maybe it'll be something to do with something else. And maybe someone will think, I need to do 4 tests because I need to test 4 different. You do whatever you want, okay? And then you just give Gary a report. And at the end of the year, you're going to find out if you get to keep your job, whether you stop being an intern, or whether it's goodbye, you've got to go and work for somewhere else. Google. Yeah. No, you are at Google. Oh. What's that? Yahoo, yeah, got to work at Yahoo. No, isn't Yahoo any good? It's got all those O's in the name. Okay, all right. Microsoft has O's in it.
Microsoft also has Bing.
Bing, they've got Bing. Is it really called Bing? Oh, that's awesome. And that's a competitor to
Google.
Bing. Is it with an exclamation mark? Oh, I didn't have to ask, did I? Oh, that's fantastic. Bing. Bing. Now, that's really funny because this is just a distraction. You're wasting our precious time here. I mentioned, this is so funny, I mentioned that film before where the same thing keeps happening all the time. Groundhog Day. Isn't there a really annoying character that keeps going Bing in that film?
Yeah.
Yeah. That's awesome. That's so funny. All right. Okay, all right. All right, there we go. Anyway, enough of that. So let's write some Java code now. So you know how to write a bit of Java code. So what I've done here is I've opened up just a session, a terminal, and I'm in a directory, and let's go ls. What's in the directory? Oh, you can't see. Sorry, guys. Bing! Bing! Okay, so here's a directory. I just typed ls and it printed the worlds. There's something called hello-world.java before that you saw. I showed you at the beginning of the lecture. A directory called code and something called mist. Don't worry about that. And object-oriented text, that's the definition of object-oriented that we showed at the beginning. So Java programs don't end with .c, they end with .java. The names are going to be camel case. Remember in C we followed the convention that if a file, so we've got these things, files that are containers that contain source code. And the source code can be functions and various things like that. And in C we had a convention for naming the files, which was if the file defined an ADT, then the file was named after the ADT. So if you had a file that defined a Q-U-E-U-E, ADT, then the file would be called Q.C. And in C we had the convention that all our ADTs started with capital letters. So the file that contained would be called Q.C starting with a capital letter. Well, Java, it's exactly the same. If the file describes something called a class, which is going to be our new equivalent of an ADT, it's going to start with a capital letter, and all our classes are going to start with capital letters. Now, most files, in fact, every file defines a class, so we're going to find that except possibly the first one. So we're going to find that all our files start with capital letters. So this hello world.java starts with a capital letter because inside it, it will be defining an ADT, or a class, actually, called hello world. So there's a hello world class in that file. Okay, now, here's the mechanics of running a program before we look at the code. In C, if I had the .c file, what would I do now? I'd compile it using GCC or something like that. GCC would compile it and also link it. And what would that produce? An executable called a.out or whatever I gave it the name of. All right, well, I'm going to compile it with the Java compiler, which is Java. Oh, I just want to see if Bing works on my machine. How do you get Bing? How do I get it? Bing.com. Is it Bing !com? No. Oh, they've missed a chance there. That's fantastic. Okay, so, all right, so we're going to go Java C to compile it, and then I'm going to say the name of the file I want to compile, which is hello world.java. Is that cool? Oh, let's turn these lights off because they're very bright. Now, I haven't hit return yet. Because actually, you know when GCC we had a whole lot of flags we'd pass in to make it be really strict and do all sorts of stuff? Because C, by default, is a fairly lax language and lets you get away with stuff, and we're trying to be really strict. Well, Java is a really strict language. So actually, there's not much we have to tell it. The only thing we have to say to be stricter is we say negative EA at the beginning. And that means enable assertions. So now Java... because in Java, the assertions work slightly differently in C. We'll talk more about it later on. But essentially, the assertion code is compiled into it. But it... oh, no, let me... I don't think I say the negative EA here. I think I'm talking crap.
Did you do it at runtime?
Yes, thank you very much, Rupert. I am talking crap because that's just what I was about to say to you. Changing the spec. Java's a bit different because the assertions are compiled in automatically, so you don't have to put a flag in. All the assertion checking stuff's compiled in at compile time, and it's just at runtime you tell it whether you want to pay attention to assertions or not. Whereas in C, you'll strip the assertions out before you compile it. In Java, you leave them in there, and just at runtime you decide whether you want to have assertions on or not. So we don't have to give it any flags. It's already as strict can be. See? Dog. And it's not really dog. Hello world does take a long time to compile. And now we've produced our output file. And it's called, can you see? Hello world.class. Now in the C world, what's actually happening in compilation is two steps. Your files get compiled into things called object files. And then all those object files get linked together to make the executable. And in GCC, we often do those two steps in one. But what's really happening is behind the scenes, if you've got 6 C files you're compiling, each of them's converted into a file with exactly the same name but a .o on the end, which is the object file, which is the machine code corresponding to that file. And then you run another pass over it called the linker, which joins them all together and plugs them together. And if this one calls a function from there, it writes the right address in and they all get joined together. And that makes an executable. Now, in GCC, we're actually doing the linking at the same time as the compiling, so you don't see that intermediate step. With Java, for reasons that will become clear later on, we don't do the linking yet. So this is the equivalent of a .o file for Java. So hello world.class is the Java program, ready to run. Now here's the difference. It's a .o file, but it's ready to run. The difference between Java and C is, or one of the differences is going to be this. C, when you've got a program, you just run it straight away. It's into machine code that the system understands If you're running it on the 4086 chip, it's in 4086 machine code. And you're running on top of Windows, and it's got all the Windows systems calls compiled into it and things like that. So it's ready to run as soon as it's compiled. But Java compiles code not to 4086 machine code, but to a special Java machine code. And to run on the actual machine, you need to run a Java interpreter. So you say, instead of, to run it if it was a C program, I'd now say hello world. Or ./hello world or something like that. That's how I'd run it if it's a C program. But to run it, oh, did I get that wrong? What did I do? Oh yes, there was a space between the dot and slash. But in any case, it wouldn't work. But let me show you not working for the right reason. But to run it, oh yeah, .class, yeah, it is called .class. Still not going to run. I can't run it, permission denied, I don't know what you're talking about, you're a lunatic. Because to run it, to run a class file, you have to run it through the Java interpreter. So you go Java hello world.class. Now, you don't say the .class. Let's see the error, no, let's see the error message we'd get if we tried to Java hello world.class. Whenever you see this error message, remember those lines, 315, that's the giveaway. Whenever you see the 315, you know. I'm joking. Just whenever you see this, the main message is at the top. Class def, no class def found error. No class definition found error. The error is I couldn't find the class. It took a long time to say it and print out a lot of stuff, but it's saying it can't find the class. And that's because it automatically sticks the word .class onto whatever you say. So it was there looking for hello world.class.class. So common mistake. So you just say to run it, hello world. Let's make it a bit wider, or the font a bit smaller. Can I make the font smaller and you see? Yep. Oops, that didn't work. Smaller? There we are. Java hello world, it'll run the program and it prints out hello world, and it worked. So that's how we run a Java program. Java is installed at the uni, so you can run it at the uni. You can try installing it at home if you want. We're using Java version 6, which is sometimes called 1.6. So if you want to, you can install it at home, but it's easy just to telnet in and do it. Let's look at the actual Java program now. Get rid of that definition. Okay, it's going to look a lot like a C program. Got comments, which is a slash and an asterisk starts a comment, and an asterisk and a slash finishes a comment, and a convention is you just keep this things going so you remember there's a comment. So this is my little header comment at the top. Here's the program. It's got the class in it that I promised you. Class hello world. So this file defines a class called hello world. You can call it whatever you want. It has a single function in it. Can you see it's using curly braces? It's a curly brace language. It uses curly braces to denote the units. So public, static, void, main, string, args. What do you think that does? Yeah, what's this function doing? Public, static, void, main. In our C land, what would that be? Main, yeah. Public, static, void, main. Well, we don't have void main. What do we have in C programs? Int main, yeah. So we actually have, our programs in C are all public and static anyway by default, but in Java we have keywords to say that because we have options. We don't have to make them public and we don't have to make them static. So this is a function called main. It's public and static. Those words will make sense tomorrow, on Thursday. It runs, it's passed a list of arguments, as you can see, just like in C. How many arguments do we pass into our C main? 2 arguments. What are they? argc and argv. What's argc? The number of command line arguments passed in. And what's argv? An array of strings that contains 1 string for each argument. Here, we're just passing in an array of strings that are the arguments. What aren't we passing in? The size of the array. Because in Java, unlike C, Java arrays know their size. So you remember all the overflows and fun stuff we're having in C, fooling around with arrays not knowing their size. In Java, every array knows its size. And if you try and access outside the bounds of an array in Java, the actual runtime system will pick it up and slap you on the wrist. It's like a valve grind sitting there, or mud flap sitting there, actually. So we don't need to pass in the size of the array because we know it. System.out.println, what's that really saying? Printf. This is how we say printf. Now, yeah. It looks complicated. Yeah, it sort of looks complicated. And look, let me show you. Here's what it would look like if I was writing in, well, you know what it would look like if I was writing in C. It'd be a little, it'd still be complicated. We'd have to import stdio.lib, because that's where printf is. It needs to know where to find the printf function. We'd have to still define the main function and do all that sort of crap. We just wouldn't have to put the class wrapper around it. But so you know how big a C1 is, a little bit simpler. My favourite language of all time, here's how you write hello world in Haskell. That's the hello world program in Haskell, the world's best language. C has a lot more overhead. It's going to cause us a bit of pain up front when we start programming. Why do you think that's, what's the design decision the language designers have made? There's a bit of extra overhead. Why do you think that extra complexity is there?
Well, because in the past computers were expensive and programmers were cheap, and now computers are cheap and programmers are expensive.
Now computers are cheap and programmers are expensive. Before programmers were cheap and computers were expensive.
So
yes?
It doesn't matter that your program's slow because it took someone less time to write it.
Oh, I see. Yeah, though this will run, the slowness of the language hasn't to do with the extra words in it. It's slightly more complex to express simple things, but hopefully the trade-off's going to be that when we express complex things, yeah.
Is it because like the interpreter, it runs independent of the system?
That is true, but that's not the reason this is here, but that's another neat feature of Java. No, it's just essentially we're going to pay a little bit of price for having a slightly more complex language, and we're going to hope that the payoff is that complex language lets us express complex things more simply. Like if our only language is UGG, and you and I have to discuss how many goats you just saw on that hill over there, you'd go UGG, 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 okay? We're done. Very simple language, absolutely brilliant. Now suppose instead we speak courtly English. You'd have to say, I say. My lord, over there on yon hill, shining in the bonny sunlight, I saw goats numbering 4 and 20. It's a ridiculously expressive language, but can you see the convenience of that is that if you wanted to talk about the opera you saw last night, it's very hard in UGG. So if we have a more complex language, hopefully it'll let us do more complex things simply, even though the simple things won't be able to be done. Yeah. Well, of course, Haskell does the complex things even more simply, but this isn't a Haskell course, so I'm not going to say anything about Haskell again. Okay, so that's our language. Now, notice there's a comment. The comment's wrapped around. This is all on one line. Comments, so we've got the same style of comments that we have in the other one. Double slash giving us to the end of the line. Asterisk slash giving us a block. Instead of saying printf, we say system.out.println. And what the system.out is essentially doing to the runtime system is it's saying, this is where you look to find the println function. It's in system.out, whatever that is. You don't know what that is yet. Just like when I go hash include stdio.lib, that's saying, look in here to find the printf function. It's just telling us where it is. Okay, that's our program. How are we going for time? I think we're out of time. Please just look it up on the web and fool around a little bit. What you should do is just try and get a program to print out the sum of 2 numbers or something simple like that. Write some trivial program. Okay. See you on Thursday.
The task pairs was done by using Wednesday